Hey, welcome. This is the web app track. This is Stefan Esser talking about utilizing code reuse and return-oriented programming in PHP application exploits.
Okay. Hello. Welcome to utilizing code reuse and return-oriented programming in PHP application exploits. I will skip my introduction, so I just want to tell you what the talk is about. Today I want to speak about something like return-oriented programming for PHP applications. So I want to take return-oriented programming to the PHP level. This will be the first part of the presentation, and the second part of the presentation will be I will demonstrate a vulnerability in PHP that can be exploited with traditional return-oriented programming methods. So during the last day, there were already several presentations about return-oriented programming or return-oriented programming style topics. So I just will give a short introduction what return-oriented programming is all about. So the basic idea of return-oriented programming is that you, instead of injecting your shellcode into an application, you will inject some kind of data that redirects the application's code flow. And the idea is to not inject code, but to use the already existing code. And the general idea is that when you have pieces of already existing code in an application, you can rearrange them in a way that they will be useful for you as an attacker. At least you hope so. But when the application is big enough, you usually will find something. So in the past, people always analyzed return-oriented programming and code reuse topic on consumer architectures like x86, AMD, 64, Spark, PowerPC, the ARM architecture because of all the mobile devices. And when you saw the talk yesterday, Dynamics guys are applying return-oriented programming to their reverse engineering intermediate language, which is called Rail. And last year there was also a paper about people using return-oriented programming against selection or voting systems. But so far there is no real research on return-oriented programming or code reuse for PHP or web applications. So when you look at code reuse techniques, you can classify them, and usually code reuse is like the topic, the major theme, and when you look at it, return-oriented programming is just a subset of code reuse techniques. And when you look at this, a subset of return-oriented programming is return to libc. And on the other side, there's something most people don't speak about, but code reuse is usually bigger. So I put in the big question mark for now. So when you look at return-oriented programming on the low-level side of maybe x86, you see that all these techniques, return-oriented programming and return to libc, based on the fact that you somehow hijack the call stack of the application. And you usually try to manipulate the call stack in a way that the return instructions that are present in the application will return to code you want it to execute. And the code you will usually execute is most of the time some useful instructions for you and then followed by the return. And in order to do this, you need full control over the stack. The example just shows one of the possible stack frames that could be used for return-oriented programming. In this case, it's some kind of system call that is executed, and yeah. So when you apply this technique directly to PHP, you will realize that that's not possible in PHP. The reason for that is there's not a single call stack that you could overwrite. The PHP application call stack is actually on 3 levels. A part of it is stored in the real stack, in the program stack. A part of it is in allocated heap structures that is most probably randomized on modern systems. And also the data segment contains pointers that are used by the executor to change the execution. So a traditional return-oriented programming attack is not possible because you usually can only override one piece of memory, but you cannot override 3 or 4 at the same time, especially if you don't know the addresses. So the other thing is when you want to return to PHP bytecode, for example, PHP bytecode is always allocated on the heap, so it will be in completely random positions on modern Linux systems. So return-oriented programming seems impossible for PHP. But if you remember this picture, there's a big question mark on the side, and we want to fill this big question mark with a new technique, which I call property-oriented programming. Short is POP. So what is property-oriented programming? The idea is that instead of overwriting some call stack or manipulating a call stack, you try to exchange the objects used in an application. So normally when you have objects, they have properties, and these objects call other methods of other objects stored in their properties. And now the idea is that I replace the objects stored in the properties, and so I can redirect the code flow. This graphic shows like the circles are just random objects, and you see one object is calling the other in the method of another object, and so on. And basically, if I can override the objects or the properties of the objects, I can choose which object is executed next. The only thing that's maybe static is which method is called. Okay, when you go down to the x86 level, this is not that easy, but this is just a general concept, and in PHP it works like this. So just believe me, like now. So when you look at PHP, the problem is this technique has some limitations, because in x86 and return-oriented programming usually can jump anywhere in the binary. But in PHP you cannot jump anywhere in the binary, you can only jump to starts of methods. So this is a limitation in comparison to other exploits. The other thing is you usually cannot just override some objects in memory, because the objects in memory are in random positions, and yeah, so that's not the way to go normally. So what you need usually is a way to create objects from remote and to fill their properties. And in PHP that's usually done by the unserialized function. I will go on that now. So unserialized is a function of PHP that is used to deserialize previously serialized data. It supports nearly all of PHP's data types. The only data type that's not supported is resources, but all the normal things like integers, floating points, booleans, arrays, strings, objects, and even references can be serialized and unserialized. And when you look at PHP applications, you will see that they are often expose this function to user input. And when you look at the history of the function, you see that there are a lot of vulnerabilities in the parser, in the unserialized parser itself in the history. So what we want to do is like create arbitrary objects. So the good thing of unserialized is it allows us to create objects and to fill all their properties. The problem you usually have when you have vulnerability that allows you to create an object is that you can only override the public properties. But with unserialized, you can override each property, the public, the private, or the protected ones. But don't mistake that for like a full unserialized of objects. You can only unserialize the instance of a class that already exists. So you cannot just inject a new method that you with bytecode or so. You cannot just inject code that gets executed. That's not possible. However, whenever you unserialize an object, PHP will check if this object has a wake-up method in its class definition. If it has a wake-up method, it will execute it. And the other thing that's new in PHP 5, although PHP 5 is already old, but in PHP 5 the whole object model was restructured, and so now objects have real destructors. So the thing is, when you unserialize an object and it gets later destroyed, the destructor will be called. In PHP 4, nothing like this happened. So this means when you unserialize an object that's existing in application, there are two possibilities where directly code will be executed. Either it's a wake-up method or the destructor will be executed if there is one. So, to show you the internal working of unserialized, I have a little example. One thing that's very important for the second part of the presentation is on the right side you see a variable table. This is an internal table of unserialized that keeps track of all the variables created by the unserialized parser during the single call of unserialized. The idea of that is when you want to unserialize a reference, you need to know which variable you want to reference to. So what happens is that unserialized creates a variable table where every variable it creates is inserted, or a pointer to the variable is inserted. And later when you create a reference to the third slot, then unserialized will look into the variable table and get the variable from there. So this example starts with unserializing in an array. This array is supposed to have 6 elements, and so you see PHP creates an array with 6 elements. Then it continues and creates all the content of the array. The first thing is the key is a 0, an integer 0, and the value is an integer 0. So it will insert it in the first slot of the array, and you see that the variable table is already filling with the array and a pointer to the first entry. And this continues to a floating point 2.0, a string ABCD, and now we get a reference. And now it's a reference to the third slot. So PHP will go to the third slot and see, oh, it's a pointer to the floating point 2.0, so this will be the reference to the 2.0. And the next element should be like any class. I call it my class in this time. It could be any class. And you can see that this has 2 properties, A and B. And PHP will now continue to unserialize each property, which again will be a reference to the class itself and a null value. Again, you see every time a variable is created, it's inserted in the variable table. And now we have unserialized the whole object, and what happens now is PHP will attempt to execute the wake up. If there's a wake up, it will be executed, otherwise it will just continue unserializing the rest. In this case, it will create an internal PHP object of type SPL object storage. We go to this later. And yeah, after that it will be finished. Okay, that's how unserialized works. And I already told you that putting user input in unserialized is maybe not a good idea. So what actually is required for an application to be vulnerable so that we can do a property-oriented programming attack? Of course, the most obvious way that an application can be vulnerable to this is if it puts user input directly into unserialized. But when you look at PHP applications, you will see that unserialized is used in very many different places, and not always it's user input that is put into unserialized. And when you look at all the different types of web application vulnerabilities, you will see that there are other kind of vulnerability classes that can be leveraged to attack unserialized. So I will go through each of the classes now. So the first one is what I repeated several times now. You just unserialize user input directly. Why would you do that? PHP application developers are usually lazy, and it's the easiest way to transfer bigger amounts of data between, for example, the client and the server.